Okay, so today is 5/31. Wow. 5 days, 6 days left, right, seniors? 5 days for seniors. Okay, so let's look at this. Movie tickets are sold by age groups. All right? So age from 0 to 12 is $5. Okay? 13 to 54 is $9. And then 55 plus is $6. So let's do a little graph. So I've got my age, 10, 20, 30, 40, 50, 60. There's my age. And then I've got my price. So I'm going to put a little graph from 0 to 12 is going to be $5. So I'm going to go up to $5. And the price is 12. Whoops. I'm on the wrong one. 0, 12, 9, 10, 11, 12. $5. No, I'm right. $5. 0 to 12 is right about there. Okay. Okay. So before I go too far, this may seem really obvious to me, but I put an open circle right there. Because if you're 0, there's no such thing as a live human baby, 0. Once you're born, it's a 1 second. So it would be an open circle, because there's no such thing as somebody who's 0 years old. Would you agree with that? So open circle, because you can't have a baby's 0 years old, right? They're going to be a minute old or 2 minutes old or whatever, right? Okay, then from 13 to 54. So 13, then, if you're 12, so 13 to 54 is $9, so I'm about $9 here. So at 12, I have an open circle. And then to 54, I have a closed circle. And I have an open circle at 12 because 12-year-olds already have a price. If you're 12 and 364 days old, you're still a 12-year-old, right? So you're going to have an open circle here because a 12-year-old and 364 days would not pay that price, okay? And then finally, my last price is 55 and up is $6. So $6 would be right here. And I'm going to put an open circle here at 54, and then I'll put an arrow, okay? That graph makes sense to me, right? Now, that does have 3 different equations, right? One equation is simply going to be, equation 1, it's going to be y equals 5, right? Equation 2 is y equals 9. And equation 3 is y equals 6, right? Those are my equations. Except, I only got pieces of those, right? So there's my 3 equations. I've got equation 1 is y equals 5. And the y equals 5 only goes so far. It's not all the way across, is it? The y equals 9 is only a piece of it, not all the way across. And the y equals 6 is only this piece of it right here, okay? So we have to show and say what? So that's only if. So y equals 5 is only if you're between 0 and 12. Right? So if you're 12-year-old, you pay that price. Y equals 9, though, is from 13 up. So we can put 12 not equal to x, but equal to 54. Okay? So if you're greater than 12, that would put you at 13, right? And then finally, y equals 6 is from greater than 54, so x is going to be greater than 54, because at 55 you pay that price, okay? Now, what I want to do is, since it is a function, I mean it is a function because it's going to pass the vertical line test, let's put it as a function. I totally agree it's a function. So here's where it gets easy. We already have our 3 equations. It is a function, so we're going to say f of x equals, okay? So I'm going to put in a brace so I can hold all my equations. Okay. Equation 1 is just equation 1 is just y equals 5. But f of x and y are the same thing, right? So instead of having to write y equals 5, I already have it. Y equals 5, right? My second equation is y equals 9, but f of x and y are the same thing. So I already have a y equals 9. And And I already have a y equals 6, but y and fx are the same thing. So instead of writing y equals 6, I've got fx or y equals 6. Now, we have to put in their domain restrictions, the constraints, because obviously you have age limits for each group. So for the $5 ticket, that's between 0 and 12. And for the $9 ticket, that's between 13, well, up to 12, and 54. And finally, if you're over 55, right, then it's just going to be greater than 54. You get a senior discount, okay? Does that seem hard? Not too bad? Okay. It is a hard lesson if you're not paying attention, but if you're with me, it's going to make it easier, okay? Now, if you need a piece of graph paper, you're going to need a piece of graph paper for this next one. Anybody need a piece of graph paper? Okay, graph paper. You're welcome. Graph paper, graph paper, graph paper. Here we go. Oh, yeah, graph paper. I mean, that's that. I'm done. No. I don't know if I have enough for the next period, but we'll make it work, huh? Girls, here we go. Oh, good. Okay. All right, where'd you let go?
To the office, his sister's here.
Okay. So let's take a look at number 2. Here is the secret to doing number 2. Let's put down our XY axis, and then I'm going to show you what I do to make it easy for me to do piecewise graphs. So the very first thing to do, let's go ahead and make our XY axis, okay? So this is question number 2. Okay. Okay. What I like to do is I like to put in my boundary points first. These are boundary lines. I'm going to show you how it works. I'm going to have 3 pieces, and the pieces are going to exist between these 3 spots. So, 1, 2, 3, 4, -1, -2, -3, -4, okay? Okay, here, watch. If you don't get anything today, watch this. This is going to make it easier for you, okay? First thing I do, on the x-axis, I find -3. I'm just going to put, now this is an imaginary invisible line, okay? But I'm going to put it in there anyway, okay? So x and -3. So I just put a line on the x-axis at -3, okay? These are not part of the graphs. They're just boundary lines. I'm going to pretend they're invisible, but it makes it easy for me. At +3, I'm going to put a line. Okay? And what I have now are 3 regions. I really have 3 regions. I've got my first region, my second region, and my third region, okay? I'm going to make 3 different graphs. And I'm going to put all 3 different graphs in each of these 3 regions. How do I get the regions? On the x-axis, I put a boundary line at -3. On the x-axis, I put a boundary line in at 3. And that's how I get my 3 regions. Okay, now, the first region is going to deal with this y equals 3x plus 8. Okay, that's going to go my first region. In my second region, between -3 and 3, I'm going to put in a y equals -2x, okay? And then finally my third region, I'm going to put in a y equals x squared minus 9, okay? Minus 3, my bad. Okay, thank you. So what I'm going to do, and I'm going to use my pencil on purpose because I might have to do some erasing because I don't want it to go out of its region. Does that make sense? So first of all, let's do the first one. So when I graph y equals 3x plus 8, I go up to 1, 2, 3, 4, 5, 6, 7, 8, right? Pencil, because I'm really not going to, I'm going to erase this. And I would go up 3 over 1, but it's not going to fit, so I'll go 3, 1, 3, 1, 1. So I would get this line here. And again, I'm going to put this in pencil for right now. So I'm going to erase a whole lot of that. Okay? There's my start at 3, I start at 8, up 3 over 1, or up 3 over 1, up 3 over 1, okay? So there's my line, okay? Now I'm not going to keep all of that. I'm going to erase quite a bit of it because what I really want is just the part that exists in region 1, right? Where it's less than or equal to negative 3, which is back here. So I'm going to erase all of this. This part of the line doesn't belong in this region. So erase it. Okay. I needed to graph the line. But after I graphed the line, I'm like, well, I only want it in region 1. So then, from here, then what I do want is this part of the graph right here. That's the graph I want right there, okay? And the rest I got rid of because it doesn't exist. It doesn't belong in that region, okay? Second region, am I going too fast? Okay, second region, to graph y equals negative 2x is like plus 0, negative 2x over 1, right? So again in pencil, because I'm going to erase some of this, I'm going to start at 0. I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, 2, 1, 2, 1, 2, 1. Okay. There's that particular line, right? That line is only going to exist in region 2. So I'm going to erase all of the part of it that does not belong. Okay, so I'm going to get rid of this little piece down here. It doesn't belong here, and doesn't belong here. Okay, how am I doing? So far, so good. And I'm going to keep what I want. So I'm going to keep this part here. I'm going to keep this one here. This is the part I want. I'm going to keep that graph right there. Okay. Everybody watching. Big point. There's no equal sign here. There is absolutely no equal sign here, right? You guys agree? So at negative 3, I have to have an open circle because that point's already been counted for once. Right here at 3, there's no equal sign. So right down here on 3, at this point, I'm going to put an open circle, okay? This graph does not have an x value of 3. This graph does not have an x value of negative 3. This graph does not have an x value of 3. And this graph does not have an x value of negative 3, okay? That's why I have to have open circle at negative 3 and open circle at 3, okay? Last graph, okay? So I've got a graph x squared minus 3. Oh, well, that's a parabola. I remember that. That's why we did that warm-up. So I know my parabola starts at 1, 2, 3, right? I'm going to do my 1, 1, my 2, 1, 2, 3, 4, my 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 4 and 16, okay? And 4 and 16 is kind of off my graph. So my parabola looks something like this. I go ahead and put it in. It looks something like this. I don't have to be perfect because I'm going to erase a lot of this. Okay. There's my parabola. You can see it in there, okay? But I don't want all of it. In fact, I don't want most of this graph at all because I only want the part that's in region 3, right? This graph's in region 3. So I'm going to erase all of it that doesn't belong. And all I want is the part that belongs in region 3, which is just this part of this graph right here. Now, I like it when the graphs connect, but sometimes they don't, right? And they don't have to connect. This is a solid dot right here because it says that this particular graph in region 3 includes 3, so a solid dot at x equals 3. Okay, that's my piecewise graph. Thumbs up, sideways, down, one sideways, one down, 2 thumbs down. Okay, all right, forgot one of these and then we're okay. So let's turn the page, right? Let's take a look at the other, okay? So now, example 3, we're going to do just the opposite. So in example 3, we're going to try and come up with the equation. We're going to look at the graph and come up with the equation. Well, again, what I like to do first is I'm going to put in my boundary lines, okay? It looks to me like they're connected here and here, okay? Right? So I'm going to put in my boundary lines, and then that's at x equals negative 1 and at x equals 2, okay? I like that. All right? Now the boundary lines are invisible. They're invisible, but I drew them anyway, okay? So I see 1, 2, 3 graphs, right? So let's go 1, 2, 3 different graphs, okay? So let this be equation 1, this will be graph 2, and this will be graph 3, okay? So see three different graphs. See graph 1, graph 2, and graph 3. And what I need is the equations for all three of these, okay? Well, line number 1 is just a y equals. In fact, it's a y equals -3. Everybody see that? Has a height of -3, so equation 1 is just y equals -3, okay? Equation 2 looks like a parabola, right? Looks like a y squared, looks like an x squared. Equation 2 looks like a y equals x squared minus 4, right? You guys see that? It's just the whole parabola hasn't been drawn, but you guys can see that's a parabola, right? Fits it, 1, 1, 2, 4, fits it perfect, okay? Equation 3 looks like it's got a slope of down 1 over 2, down 1 over 2, but you got to be careful on this one. You got a y equals down 1 over 2, but it originally started right here. Okay, originally started here, but it got erased, right? You originally had a y-intercept of 1, so you got to put the 1 in there because that's how you'd graph it, but it got erased. So it had a y-intercept of +1. Does that make sense? If I were to graph this line all the way through, now I'm just going to erase what I have. Okay, we're on our way. So, equation 1 exists between -4 and -1, right? Okay, graph 1 exists between -4 and -1, right? So that's if it's between -4 and -1. Okay, line 1 exists between -4 and -1 on the x. The parabola exists between -1 and 2. Okay. Thank you. You're ahead of me as always. I'm going to fix it. Can't be. Nope. Nope. Hold that thought. Okay. Because I thought you'd be the one to correct me on that, but I'm doing this on purpose, Claire, because it's going to bring in a good point. Okay. So then, equation 3 exists between 2 and 3, 4, 5, 6. Right. Now, Claire brought up a really good point. Okay. And it's up to you. It doesn't matter because we don't know. So look right here. Everybody look where my finger is. Look right there. Right there. See that? Everybody see that spot? So that spot can only count once. Can't count twice. It can either count for the first graph or the second graph, but it doesn't matter. Morelia, you get to choose. Do you want this point to go with graph 1 or do you want this point to go with graph 2? It doesn't matter. Which one do you want? 1 or 2? Say it. 1 or 2? 1 it is. So it goes to 1, then equation 2, watch the whiteout, can't have it. Right? Because you can only count that point once. Okay? Now, right here. Right here. You guys looking right there? Ann Lynn? Doesn't matter to me. It's up to you. Do you want this point at 2 to go with graph 2 or with graph 3? Which one? Doesn't matter. 2 it is. So 2 gets to keep the equal sign, but graph 3 can't because you can't count it twice. Claire, that answers your question because you could answer this the other way and still be correct, right? Unless we had more information, which we don't, okay? So now we're ready to put it all together. So we're going to say, okay, y and f of x. Is it a function? Heck yes. You guys agree? It is a function. So we're going to say, all right, the answer's got to be f of x equals, I'm going to put in my brace so I can hold the whole thing together. Okay? Equation 1 is y equals -3, but y and f of x are the same thing. So instead of y equals, it's f of x equals -3, and that's if we're between -4 and -1. Equation 2, y equals x squared minus 4, but y and f of x are the same thing. So instead of y, we'll go f of x equals x squared minus 4, and that's if it's between -1 and 2, okay? And then finally, to finish it, y equals -1/2 x plus 1. Y and f of x are the same thing. We don't need to write y because it's already right there. So we'll go f of x equals a -1/2 x plus 1. And that's if we're between 2 and 6. Uh-oh, I made a mistake, but I'll fix it. Come on, Katie. Made a mistake. Haha, I did. There, I fixed it. All right, that's what I have. Oh my goodness, 666. I hope. Don't be I guess don't be too suspicious, because there it is, huh?
You can't do this homework, babies.
All right.
I don't want to be cursed.
Well, there it is. Anyway.